Hello dear students and welcome to the amazing platform of Technogate. Well, today we will discuss the Ecet paper of Andhra Pradesh state of the year 2025. Okay, so there are total 25 questions and each question carries 1 mark. There is no negative marking. Okay, so we will discuss all the questions one by one. Let's start. Okay, so the very first question of chemistry. Okay, here we will discuss the chemistry portion. See, the very first question. Consider the elements with atomic number 1 to 20. Okay, we need to consider all the elements from the atomic number 1 to 20. Now we need to tell the number of elements with only one unpaired electron. Okay, how many number of elements are there with only one unpaired electron in their ground state. Ground state simply means when an element is not in the excited state. Okay, their regular electronic configurations here we are talking about. So, see, very easy. What would we do? We would write the electronic configuration of all the elements. Okay, we would write from 1 to 20 the electronic configuration of all the elements, and we would see how many number of elements are having only one unpaired electron. Okay, so let's start. Hydrogen, the atomic number 1. Okay, the electronic configuration is what? 1s1. Then we are having helium, 1s2. Lithium, 1s2, 2s1. Beryllium, 1s2, 2s2. Boron. Okay, the atomic number 1, 2, 3, 4, 5. Here the atomic numbers are mentioned. 1s2, 2s2, 2p1. Next is what? Carbon. 1s2, 2s2, 2p2. Nitrogen. 1s2, 2s2, 2p3. See, 2, 4, 5, 6, 7 electrons. Okay, oxygen. 1s2, 2s2, 2p4. Okay, next is what? Fluorine with atomic number 9. 1s2, 2p2, 2p5. Then after fluorine, we are having neon. 1s2, 2s2, 2p6, 6, 2, 2, 10 electrons. Okay, I hope so you all know now the electronic configurations. Okay, next we are having sodium. So we would write it like this. Neon. Neon means what? The electronic configuration up to number 10. Okay, 3s1. Okay, magnesium, that is what? 3s2. Aluminium, atomic number 13. After aluminium, what are we having? Silicon. Okay, 3s2, 3p2. Sulfur next. Sorry. Phosphorus. Okay, then next is what? Sulfur. Okay, we are writing the electronic configuration of all the elements up to atomic number 20. Fluorine. Okay, this is still atomic number 70. After fluorine, what are we having next? Argon. Okay, so till now we have completed ED. Okay, 18 number of atomic number. After that we are having potassium. Now we would write in terms of argon. Argon means what? 18, up to 18 electrons. And here after 3p6 the electron enters where? In the 4s. And the last one is what? Our calcium. Now see, what is our question? Our question is how many number of elements are having just one unpaired electron? Okay, so see, hydrogen. Here in hydrogen, okay, whatever. In hydrogen, we are having what? Just one unpaired electron. Okay, helium, the 2 electrons are there. So now in lithium again, what are we having? One unpaired electron, right? 2s1. So there is one unpaired electron. Then next is boron. In boron also we are having one unpaired electron. See, it is 2p1. Okay, 2p1. Then here 2 electrons, here 3 unpaired electrons. Here we are having 4 unpaired electrons. Here, not 4 unpaired electrons. Here, what would be here? See, the like this, 1. Here in P, what happens? Like this, 1, 2, 3 and 4. So here we are having what? 2 unpaired electrons here. Okay, here again we are having what? 1 unpaired electron, 2p5. Okay, 1, 2, 3, then again 4, 5, then just 1. We are having 1 unpaired electron there. Here then in sodium, here the orbital is what? Completely fulfilled. Here in P we are having again what? 1 unpaired electron in the ground state. Then here we are having 2 unpaired electrons. Here we are having 3 unpaired electrons. Here again we are having what? 2 unpaired electrons. Then in chlorine also, what are we having? 1 unpaired electron. This is fulfilled, completely fulfilled orbital. Here in potassium also we are having what? 1 unfilled, just 1 unpaired electron, right? And this forest state is a complete. We are having complete s orbital, just 2 electrons. So how many? 1, 2, 3, 4, 5, 6, 7 and 8. 8 elements are having what? 8 elements. 8 elements are having what? 1 unpaired electron in their ground state. From when we are talking about atomic number 1 to 20, there are 8 elements that are having 1 unpaired electron. Okay, it could be either in the form of what? See, either it is in form of S1 or it is form of P1 or it is in the form of P5, right? So here also we are having 1 unpaired electron. Here in P. Here also we are having 1 unpaired electron, and when we are having what? P5 means 1, 2, 3, 4 and 5. So here also we are having what? 1 unpaired electron. So we, how many we saw? Total 8 elements are there which are having 1 unpaired electron in their ground state. Clear? So the answer for the first question is what? 8. Okay, let's move to the next question. Okay, identify the orbital which has lobes not orienting on the axis, means whose lobes are not along the axis. Okay, so px, if we talk about px, let's consider this is our x-axis. So p orbital are what? Dumbbell shaped. Okay, so this is what our px orbital. So the lobes are what? Are along the axis. Py, this is x, this is y axis. Okay, so in py also the lobes are what? Along the axis. So this is also not correct answer. Now if we talk about d orbitals, so in d orbitals we are having what? dxy, dyz and dxz. These orbitals what? Here the lobes. This is what? Double dumbbell shape. The orbitals are what? Double dumbbell shape. And these three orbitals out of the total 5, dxy, yz and zx, these are having their lobes in between the axis. Okay. These orbitals are having their lobes in between the axis, and the remaining two orbitals, that is dx square minus y square and dz square, their lobes are present where? Along the axis. Okay, so these two orbitals are having their lobes along the axis. So our correct option would be what? DYZ. Here the lobes are present where? In between the axis. When we are talking about dx square minus y square also, so the lobes are what? Here. The lobes are along the axis. Okay, so out of these four options, the correct option is DYZ. Okay, DYZ. Their lobes are where? In between the axis, like this. Okay, like this. Okay, so the lobes are where? This is x-axis, this is y-axis, or consider z. Okay, so this is, the lobes are in between the axis. So the correct option is what? DYZ. Clear? Let's see next question. Okay, what are we given? We are given 4 N, L, M and S. 4 quantum number values we are given in this question. Okay, this N, L, M and S, we know that these are what? These are quantum numbers. N, principal quantum number, L, azimuthal quantum number, M, magnetic quantum number and S, spin quantum number. So we are given the quantum numbers. Now we need to find out that which of these are having the impossible set, impossible quantum number set. Okay, for an electron. Okay, okay, so we are given what? N, L, C, N, L, M and S values. First of all, N is our principal quantum number, so it can have any value like 1, 2, 3, whatever, like this. Okay, then when we are talking about L, when we talk about L, then depends on which orbital it is there, whether S, P, D, F, right? S, P, D, F, azimuthal quantum number 0, 1, 2, 3. The value of L are like this. Then M values are what? Minus L, including 0 to plus L. Okay, so these are what? M possible values of M. Okay, that is minus L, including 0 to plus L. And spin quantum number can have any value, plus 1 by 2 and minus 1 by 2. Now look over here. What are we given? That value of N equals to 2. No problem. Okay. Value of L is given as 0. Okay. Now if value of L is 0, then the possible M values are what? Minus L, including 0 to plus L. Means minus 0 for this L value. M values could be what? Minus 0, 0 and plus 0. Ultimately what? 0. S could be anything, plus 1 by 2 and minus 1 by 2. Here they have given us L value what? Minus 1, which is not possible. So this is our correct option. This set of quantum number is not possible, because here M value is given what? L value is given as 0 and M value is given as what? Minus 1, which is not possible. So this is our correct option. Let's see other options also. Here N value is 3. No problem. Here L value is again 0. Okay. Now M value here it is given 0. Yes, this is possible for L. M values would be what? Minus L, 0 to plus L. Okay. And spin, it could be anything, plus 1 by 2, minus 1 by 2. Okay, correct. These 4 quantum numbers, these are correct. These are possible for an electron. These 4 quantum numbers are possible. Next, N value is given as 4. Okay, no problem. Again, L value is given 1. Okay. M values could be what? Minus 1, 0, plus 1. So here we are given plus 1. Okay, possible. Spin, again possible, plus 1 by 2 or minus 1 by 2. Okay. Because for L value, the N value could be what? Minus L, including 0 to plus L. So minus 1, 0, plus 1. All possible. In last option, N value is 3. Okay. This is L value is given as 2. Fine. This -1, yes, because it would have values what? -2, -1, 0, +1 and +2. All these values are possible for M. So we are given what? -1. This is again possible and it's been -1/2. So this set of quantum number is what? Also possible. Clear? So our correct option would be what? Option number 1, that this L value 0 and for that M value -1. This is not possible. So the correct option would be option number 1. Let's see next question. Now, in this question, what is it asked? Consider the elements with atomic number 8, 9, 11, 19 and 20. Now the number of ionic compounds, possible with the elements having with this atomic number. Okay, first of all, let's write what these elements are. So atomic number is what? 8, 9, 11, 19 and 20. So what are these elements? Element with atomic number 8 is what? Oxygen. 9 is what? Fluorine. 11 sodium. 19 is potassium. 20 is what? Calcium. Now how many ionic compounds? Ionic compounds are possible. Okay, ionic compounds are what? In which we are having what? Cation, anion, ions and electrostatic forces of attraction. That are formed by the donation of electron, acceptance, transfer of electrons. Okay, the compounds which are formed by what? Transfer of electrons. Okay, so by the transfer of electrons. So these three we are having what as cations. These would act as cation metals. Okay, and these would act as what are anions. Right, so let's see the number. Sodium, first of all, this would act as a cation and it would form compound with both of them. So sodium oxide is possible and sodium fluoride. Okay, these two compounds it would form. Then potassium, again potassium oxide it would form and potassium fluoride, with both of them it would form compound. Then what are we having? Calcium. So calcium oxide would be formed and calcium fluoride. So how many? 1, 2, 3, 4, 5, 6. Total 6 compounds, 6 ionic compounds are possible. Okay, with these elements, how many compounds are possible? This option number 1, 6. 6 ionic compounds are possible. Clear? Have a look. Next. Okay. Next question is what? In which of the molecules lone pair bond pair of electron ratio is 2:3? Okay, here what do we need to do? We need to find out lone pair bond pair ratio. Okay, let's write first of all our molecule. Okay, whatever our molecule is. Then let's write its lone pair. Then write its bond pair. And then we would write their lone pair bond pair ratio. Okay, so our molecule, first molecule is what? Chlorine. It is formed like this, right? Okay, it is formed like this. Now here, how many number of lone pair on chlorine? 1, 2, 3, 4, 5 and 6. So we are having what? 6 lone pairs. The number of bond pair, this is just one bond is present, so 1. So their lone pair bond pair ratio is what? 6:1. Okay. Next molecule, oxygen. Oxygen molecule is like this. Okay. So how many lone pairs are there? 1, 2, 3, 4. So there are 4 lone pairs. And bond pairs are what? 2. So it is what? 4:2. Or you can also write it as 2:1. Okay, in question 2:3 is asked. So this is also not our correct answer. This is also not our correct answer. Then next, HCl. This is how our HCl molecule is. Okay, this is our HCl molecule. So the number of lone pairs are what? 1, 2 and 3. So here we are having what? 3 lone pairs, and number of bond pair, this is what? Our bond pair. So 1. So here our ratio is what? 3:1. Now our last option, and 2. Nitrogen molecule. How nitrogen molecule is formed? There are triple bonds. Okay. 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10. Okay. So here 1 and 2. How many lone pairs are there? 2. And bond pairs? This 1, 2 and 3. 3 bond pairs are there. So the ratio is what? 2:3. So this is asked in our question that lone pair bond pair ratio is what? 2:3. So in nitrogen molecule we are having what? Lone pair bond pair ratio is what? 2:3. So the correct answer would be what? Nitrogen. Okay. So our correct answer would be nitrogen. This is our nitrogen. There are triple bonds and one lone pair on each nitrogen atom. Clear? Next. Okay. So what is our next question? How many moles of urea? Yes. What is our next question? How many moles of urea is present in 250 ml of 0.2 molar solution of it? Okay. So here what are we given? Molarity. We know what is the formula for molarity. Molarity is what? Number of moles of solute dissolved in per liter of solution. Here what do we write? Volume of solution, and it should be in what? In liters. Okay, in liters. So here we need to find out what? Number of moles. Molarity we are already given 0.2 molar. So here we have put molarity. Number of moles we need to find out. Volume of solution we are already given 250 ml. Okay, but it is in ml. So when we would convert 250 ml into liter, so we would multiply it by 10 raised to power minus 3. From milliliter we have converted it into what? Liters. Here we want the answer in liter. So what would be the number of moles? 0.2 into 250 into 10 raised to power minus 3. Okay. Then we would solve it. One by 20, or it would come out to be 0.005. 0.05. Okay, so this is what our number of moles. See, just simple formula, molarity is what? Number of moles of solute dissolved in per liter of solution. Just we were given this molarity value, that we have put it in the formula 0.2. Number of moles we need to find out. Volume of solution in liter. So that is what? 250, and it was given in ml. Okay, so we know that 1 liter is what? Equals to 1000 ml. Do not make mistakes over here. And 1 ml is what? 10 raised to power minus 3 liter. Okay, I hope these are very basic conversions. Okay, so just we converted it. 250 into 10 raised to power minus 3, and we just solved it. Okay, so what did we got? This, it would go over here, and we got our number of moles, which is what? 0.05. So the correct option would be what? Option number 3. Okay, clear? Next question. See, 1 ml of x. Okay, x ml of 0.1 molar NaOH solution is diluted. Diluted means what? We added water in this solution to get 250 ml of 0.01 molar solution. Okay, 0.01 molar solution, then the value of x is. Here we need to tell the value of x. Matlab how much, meaning how much volume of 0.1 molar NaOH we would require for what? converting the solution into what? 0.01 molar. Okay. So see, we know that in both the solutions, what did we do? We just added water. The number of moles of solute did not change. Okay. Here, the number of moles of solute for 0.1 molar NaOH is equals to what? Here, we are just adding water. We are not changing the number of moles of solute. So here it is equals to what? Number of moles of solute for 0.01 molar of NaOH. Okay, for this solution, the number of moles are what? Same. What is the formula? See, molarity. We know it is what? Number of moles upon volume of solution. So, number of moles is what? Molarity into volume. So, for this we would write what? Molarity into volume. Okay, let's consider it as M1V1 is equals to what? M2V2, because in both the cases number of moles are what? Same. So, here by using this formula, the number of moles formula is what? Molarity into volume. So, here in place of number of moles, what are we writing? Molarity of this solution into volume of this solution is equals to molarity of this solution into volume of this solution. Molarity here, what are we given? 0.1. Volume we need to find out. We are given it as XML. Here the molarity is given as 0.01. See, and the volume is what? 250 ml. We would simply solve it. So our answer would be what? 25. 25 ml. 25 ml would be our correct answer. Here, option number 2. Okay, we simply solved it. Okay, in both the cases, the number of moles are same of the solute, that is of NaOH. There is no change in it. Clear? So our correct option would be what? 25 ml. Option number 2. Okay, next question. Okay, here. This is an interesting question. Here, what do we need to do? Now, 3 into 10 raised to power 22 molecules of sodium carbonate. Okay, sodium carbonate whose molecular weight is what? 106. These are present in 500 ml of solution. The normality of the solution is, and here we are given the N, that is Avogadro's number. Now simply let's write the formula for normality. What is the formula for normality? That is gram equivalent of solute present in per liter of solution or volume of solution in liter. Okay, volume of solution in liter. This is what the formula for our normality, gram equivalents of the solute that are present in the volume of solution. Now, what is gram equivalent of solute? So, this is what? Mass of solute upon equivalent weight. Okay, mass of solute upon equivalent weight of solute, and we are having what in denominator? The volume of solution in liter. Okay, so here what do we put? What is gram equivalent of solute? Mass of the solute and divided by the equivalent of the solute, equivalent weight of the solute. Now see over here. Look, We are not given the mass of the solute also. What are we given? That we are having 3 into 10 raised to power 22 molecules of Na2CO3. See, understand it with the help of, let's take a fresh page. Okay. See, what are we given? That we are having 3 into 10 raised to power 22 molecules of Na2CO3. Now let's, and its molecular weight. Its molecular weight is given what? 106. Okay, so 106 is what? Its molecular weight. See, with the help of mole concept, we know that 6 into 10 raised to power 23 molecules of sodium carbonate's weight is, okay, weight of, this is what? This is what? 6 into 10 raised to power 23 is what? 1 mole. 1 mole of Na2CO3, its weight is what? 106. This is its weight. Mole concept, simple mole concept. That we would talk about 1 mole. 1 mole of any compound, molecule, anything. Okay, what are we having there? In 1 mole, we are having 6 into 10 raised to power 23 molecules, and that are having weight equal to the molecular weight, that is 106. Here we want to find out the weight of what? 3 into 10 raised to power 22 molecules. So we would simply use the unitary method, that 1 molecule of Na2CO3, it is having weight what? 106 divided by 10 raised to power 23, and 3 into 10 raised to power 22 molecules of Na2CO3. These are having weight equals to what? 106 into simple unitary method. Okay, so this much weight. Simple unitary method we have used, that 1 mole or this many molecules of sodium carbonate, they have weight equals to what? 106. So 1 molecule it would go in where? In the denominator, simple unitary method. So 1 molecule would be having weight this much, and then 3 into 10 raised to power 22 molecules of sodium carbonate, this would be having weight this much. Let's simplify it a little bit. Okay, we won't solve it completely. 106, this 106 by 20. This is the weight of what? Mass of 3 into 10 raised to power 22 molecules. Okay, so this is the mass. 106 by 20. Okay. Now here everything is erased. Okay, let's write again. Normality is what? Mass of solute divided by equivalent weight of solute and this whole is divided by volume of solution in liters. Okay, volume of solution in liters. This much we solved, that normality, because it is what? Gram equivalents present in per liter of the solution. Gram equivalence is what? Gram equivalence of solute is what? Mass of solute upon equivalent weight of the solute. Now one more thing, this is what? Sodium carbonate, Na2CO3. It would dissociate Na plus 2 plus CO3 minus 2. So it's, when we would write its equivalent weight, it would be what? Molecular weight divided by 2, because here what do we use? Valency. Here the valency is what? 2. Okay, so equivalent weight would be what? Molecular weight divided by 2. Let's put the values. Mass of solute right now we found out 106 by 20. Okay, now equivalent weight of the solute is what? 106 and divided by 2. Okay, that is its valency. The volume of solution, we need it in liter. So what are we given? 500 ml. So we converted it into what? Liter. 500 ml is equals to 500 into 10 raised to power minus 3 liter. Now we would simply just solve it. Okay, so what is it? 1 by 10. Let's write it like this. Simple maths. 2 by 10, that is 0.2 normal. Okay, so our correct option would be this, 0.2 normal. Okay, just simple maths. Just simply solve it. Just put all the values. Okay. Clear? What did we do? We found out the mass for the 3 into 10 raised to power 22 molecules first of all. That would be what? The mass of our solute. And we know that 6 into 10 raised to power 23 molecules, they are having mass what? 106 grams. So for 3 into 10 raised to power 22 molecules, just with the help of simple unitary method, it would be 106 divided by 20. And just we put all this value in what? In our formula of normality. Normality is what? Gram equivalents of the solute that are present in the per liter of the solution. Clear? Okay. Next question. Identify the pair containing only Lewis acids. Okay, only Lewis acids we want. So our first pair is what? BF3 and NH3. This is not correct option. Okay, BF3. It acts as a Lewis acid. But NH3 is what? A Lewis base. What is Lewis acid and Lewis base? Lewis acid, that would what? Accept lone pair of electrons. Okay, it accepts lone pair of electron. And what is a Lewis base? They donate lone pair of electrons. Okay, so these are what? Electron rich. These are what? Electron deficient. Okay, these are what? They accept it. Okay, so these are what? Electron deficient compounds. And these are what? Electron rich compound. Okay, so the very first option is what? BF3 and NH3. No, this is not correct option. BF3, it acts as Lewis acid. But NH3, it is what? It is a Lewis base. Our next option here, H plus and BF3. Yes, BF3 acts as a Lewis acid and H plus. It is again what? An electron deficient compound. Okay, there is no electron in H plus. So the correct option would be what? Option number 2. This would be the correct option. Option number 2. H plus and BF3. H plus is what? Electron deficient. It would accept a lone pair of electron. Okay. Now F negative. F negative is what? Electron rich. It is already having one extra electron. So it would like to donate its extra electron. So this is what? These both. This and in water molecule. In water molecule also what? Lone pair of electrons are present. So they both act as what? Lewis base. Okay. They both would act as what? Lewis base. Then here again our ammonia is what? Lewis base. Okay, so the correct option would be H plus and BF3. Okay, so do make this correction. The correct option is H plus and BF3. This pair would act as what? Lewis acids. Okay, next question. Here. 4 gram of NaOH is dissolved in 1 liter of solution. Okay, 4 gram of NaOH is dissolved in 1 liter of solution. Now we need to find out what? The pH of the solution. Okay, so what are we having? 4 grams of NaOH. Let's find out the number of moles of NaOH. Because whenever we write this pH, what do we require? We require concentration. Right? So number of moles of NaOH. So this would be what? Mass of NaOH divided by molecular mass of NaOH. So what is the mass of NaOH? We are given 4 grams, okay, and molecular mass of NaOH is 40. Okay, 40. NaOH, Na. Oh, H. Okay, its molecular mass is what? 40. Sodium is what? 23. Oxygen is 16 plus 1. So it would come out to be 40. Okay. So the molecular mass of NaOH is 40. So what are we having? 1 by 10 or 0.1 moles, or we can write it as 10 raised to power minus 1 moles of NaOH. Clear this much? So how many moles we are having? 10 raised to power minus 1 moles of NaOH. I am clearing this much. Okay, clear this much? Now, so how would NaOH dissociate? It would dissociate to give what? Na plus and OH negative. The number of moles of NaOH, right now we calculated how many? 10 raised to power minus 1 moles of NaOH. So it would dissociate to give us 10 raised to power minus 1 moles of Na plus sodium ions and 10 raised to power minus 1 hydroxide ions. Okay, this is how it would dissociate. From here we cannot calculate pH value. From here we can calculate pOH value. Okay, and this would be what? Negative log of OH, negative ion concentration. Here, negative log. Now, what is our hydrogen ion concentration? It is 10 raised to power minus 1. We would solve it. This would come ahead. Negative minus 1. It would become log to the base 10. And this minus minus is 1 and log to the base 10 is also 1. So what are we having? pOH value as 1. What is our pOH value? Is 1. Is this what we are asked in the question? No, we are not asked, but you would definitely get this option. Okay? They did not ask us pOH value. They asked us pH value. So we know that pH plus pOH of any solution is equals to 14. pH we need to find out. pOH we have found out that it is 1. So from here, the pH value is what? 13. Okay? P and dash. It is what? 13. So what would be our correct option? 13. See, this is 13 is our correct option, but the wrong option would also be there in the 4 options. So use your brains wisely. Okay? That whether we are finding OH values, pOH values, what we are finding. Clear? First of all, we need to find out the number of moles, because here we need to put concentration terms. Okay? Okay. Next question. Now, number of coulombs corresponding to 1 moles of electron is equals to Faraday. This is the definition of what? 1 Faraday. 1 Faraday is what? Charge carried by 1 mole of electrons. Okay, this is what? 1 Faraday. And 1 Faraday's value is what? 96500, or what can we write it? 9.65 into 10 raised to power 4. So our correct option would be option number 2. Okay, this is what? This is the number of coulombs corresponding. See, it is very simple. Here just it is asked that 1 mole of electrons, how much charge they are having. See, 1 electron, on 1 electron the charge is what? 1.602 into 10 raised to power minus 19 coulomb. 1 mole of electron simply means what? 1 mole of electron means what? How many electrons we are having? 6.023 into 10 raised to power 23 electrons. Now the charge on 1 mole would be what? charge on 1 mole of electron, it would be what? 1.602 into 10 raised to power minus 19 into this term. Because in 1 mole, this many electrons are there. When we would solve it, we would get 96500. Okay, because we are not having 96500, but we are having 9 point. See, here let's consider a decimal is over here. So 1, 2, 3 and 4 places we are moving it. So what can we write it? 9.65 into 10 raised to power 4. So the correct option would be what? Option number 2. Okay, 1 Faraday. Because on 1 electron this much charge we are having. So on 1 mole we would be having charge. 1 mole means what? 6.022 into 10 raised to power 23 electrons. So the charge would be, we would get by simple multiplication. Okay, clear? And this is the definition of Faraday. 1 Faraday. Okay, next question. Aqueous solution of which of the following does not act as electrolyte? Very simple. For electrolyte, a compound need to get dissolved in the solution. There should be charges to carry the current. Okay, so urea, it is an organic compound. What is it? Organic compound. Its aqueous solution means its solution in water. It won't dissociate. Urea is what? NH2CO, NH2. So it won't act as an electrolyte. Then we are having what? Copper sulfate. So yes, in water it would dissociate into what? Cu plus 2 and SO4 minus 2 cation, and hence it would carry charge. Silver nitrate we are having AgNO3. These are what? Strong electrolytes. Ag plus and NO3 negative ions, it would dissociate. Sodium chloride, so we all know NaCl, it would dissociate into what? Na plus and Cl negative. So these all would act as what? Electrolytes in their what? Aqueous solutions. Aqueous solutions means what? In water. Okay, and urea, it is an organic compound. So it NH2CO, NH2. It does not act as an electrolyte in the aqueous solution. Clear? So correct option is option number 1. Next question. The amount of silver deposited when 9.65 coulombs of electricity is passed through an aqueous solution of silver nitrate. Okay, here we are given the value of 1 Faraday. 1 Faraday it is also given. So by Faraday's, I think, first law, Faraday's first law of electrolysis, we know that it is equals to what? E into Q. Okay, E into Q. This is what our formula, mass of the substance deposited, where M is what? The mass of amount of the substance, or mass of the substance deposited. E is what? Our electrochemical equivalent. But here we are not given it. So we know its formula. What is its formula? E is equals to E upon F. Okay, what is this E by F? This is equivalent weight. And this is what? Our Faraday constant. That is what? 96500. Okay, so we would just put it, because we are not given electrochemical equivalent. So this formula we would form it as E upon F into Q. Now the mass. Now this is what? Our equivalent weight. So silver's equivalent weight is what? When we are talking silver, so it's 108 and divided by 1, because the valency, silver nitrate is what? Like this. So here the valency is what? It would be dissociated into Ag plus and NO3 minus. So it would be divided by 1 only. Okay, so the equivalent weight would be the same. 108. 1 Faraday is 96500. The charge we are given 9.65. Okay, but here we are asked not in grams but in mgs. Okay, this would come out to be in what? Gram. This is what in grams. Now here they have asked us that the amount of silver in mg. So to convert gram into milligrams, what would we do? Simply just multiply by 1000. Now this is what in mg. So it would come out to be what? 10.8 mgs. Okay, this option number 3. The correct option would be what? Option number 3. 10.8 mgs. Clear? Here in the question, this value, it would come out where? In the grams. Here in the question they asked us the amount of silver in mg. Okay, that's why we have converted grams into what? Milligrams. Next question. Now, the standard electrode potentials of zinc, silver and copper, these are given to us. Identify the correct statement. We need to identify the correct statement. First of all, let's arrange them. Okay, so in the increasing order, because in the electrochemical series, okay, we know that elements are arranged what? In the increasing order of their standard electrode potential. Right, so increasing order, so first of all there would be what? Zinc minus 0.76, then next we are having copper, quartz, and then the last one would be what? Silver. Okay, that is Z plus 0.80 volt. This is what we have arranged in the increasing order, like in case of the electrochemical series. In electrochemical series, these are arranged like this. So from here to here, what happens? Their electrode potential is what? Increasing. Standard electrode potential is increasing. Okay, standard electrode potential is what? Increasing from zinc to silver. Or we can say that here, this silver is having more oxidizing power. Okay. Here, from here to here, they become what? A strong oxidizing agent. Strong oxidizing agent means what? They would oxidize the, this would oxidize the elements that are present above it. Okay, and itself would get reduced. It has a tendency to what? Gain electron. Their standard electrode potentials are increasing. In the electrochemical series, see, their standard electrode reduction potentials are increasing. They want to gain electrons. As we are moving down, they want to gain electron and oxidize the other ones which are present above them. Now let's see which statement is correct. Ag can oxidize zinc and copper. Okay, Ag. This is our silver. Okay, it can oxidize zinc and copper. But see here, it is what written? Zinc and copper. We talk about their ions. Okay, it should have been like this, then this statement would have been correct, but here zinc and copper is written, so this is not correct. Okay, so this statement is not correct. We talk about what? We talk in the form of what? Ions, like ions. Here it can oxidize what? It cannot oxidize. Okay, so here this is not the correct option. Then silver can reduce zinc and copper ions. See, silver, it can reduce this and this. No, they oxidize the elements which are present above them. Okay, this is a strong oxidizing agent. It itself wants to get reduced. It wants electron. So, it won't reduce it would rather oxidize. Okay, silver, it would rather want to oxidize zinc and copper. Okay, it would want to oxidize. So this option is also wrong because here reduce is written and not oxidize. What is the third option? Zinc can reduce Ag plus and Cu plus. Yes. Okay, zinc. It is These two are what? Better oxidizing agents. It itself would like to lose electron and give to copper and zinc, silver. Okay, so this option is correct, that zinc can reduce Ag plus and Cu plus 2. See the reactions if this is like this. Let's take copper. This is very popular reaction, displacement reaction. This reaction happens. Okay, here what is happening? This is in Cu plus 2. Zinc here is what? In 0. So it would get converted into plus 2 and this would be what? Reduced. So this option is correct, that zinc, it can reduce Cu plus 2. It would reduce this Cu plus 2 into what? Cu, and it itself got what? Oxidized. Similarly, if it would react with any, say, silver nitrate, so it would do what? It would reduce it and it should itself get oxidized. Okay, here we are having what? Ag in plus 1. Okay, so it would be what? Reduced. This reaction is possible. Okay, and this from 0 to it would go into what? Plus 2. It would get oxidized. So the correct option would be what? Zinc can reduce Ag plus and Cu plus 2. Okay. So that would be what? Our correct option. Clear? So read the question, read the statements carefully. Copper can oxidize zinc and silver. So this is again a wrong statement. Okay. In the removal of permanent hardness of water by permuted process, sodium ions of permuted, these are exchanged with which ions? So see the permanent, which ions of the water? So the permanent hardness of water, if we talk about the permanent hardness of water. Okay, so the permanent hardness of water is due to what? Calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. These are what? Responsible for the permanent hardness of water. When here the sodium ions, okay, the sodium ions, the cations, they replaces these cations like Ca plus 2 calcium and magnesium ions. In the permuted method, they replaces what? This calcium and the magnesium ions. These are responsible for what? For the permanent hardness of the water. Clear? The correct option would be option number 3, calcium and magnesium. The permanent hardness of water is due to them. Now, here we need to calculate what is the degree of hardness in parts per million. Okay, here in parts per million of a sample containing 90 mg of magnesium chloride, and the molecular weight of magnesium chloride is given what is 95, and in 2 kg of water sample. So here what do we need to do? And express it in terms of the equivalence of calcium carbonate. Here we need to find out the degree of hardness of water. Okay, the degree of hardness of the water, but in ppm. Okay, in ppm we need to find out the degree of hardness of water. Now if we talk about the hardness of water in ppm, if we want to talk about the hardness of water in ppm, and that too in terms of what? Calcium carbonate. So here we need to find out the mass of calcium carbonate, and it is divided by what? The volume of water. Okay, here we need to do what? Volume of water in liter. Now from this formula we are right now having nothing. From this formula we are neither having mass of calcium carbonate, neither we are having, nor we are having the volume of water in liter. So first we need to find out both of these. Okay, so first of all, what would we find out? The mass of calcium carbonate. Okay, the mass of calcium carbonate. So how is it calculated? So mass of calcium carbonate, it is calculated as the mass of hardness producing salt mass of hardness producing salt divided by the molecular weight of salt, the same salt. Okay, that is what producing the hardness, molecular weight of the salt into molecular weight of calcium carbonate. Okay, here we would write not mass but molecular weight. Molecular weight of calcium carbonate. Yes, we are having all these values. The mass of hardness producing salt, it is given to us as what? 19. Divided by the molecular weight of the salt, it is given as 95 into. Now the molecular weight of calcium carbonate, it is 100. Okay, 100. So this is our what? This came out to be 20. Okay, 20 grams. So this is what our mass of calcium carbonate. Okay, mass of calcium carbonate, it came out to be what? 20 grams. So here we would put what? 20 grams. Right now we are not having what? The volume of water. Here in this formula, what are we not having? The volume of water. But we are having the water sample's weight. Okay. See, one more formula that we know, that density is equals to mass divided by volume. Okay, density is equals to what? Mass divided by volume. From here, the volume in liters, we can find out mass upon density. So what is the mass given of water sample? It is 2 kg. Density is what? 1 kg per liter. Okay, so it would come out to be 2 liter. So what did we got? The volume of the water as 2 liters. See, density is equals to mass upon volume. And the density of water in, it is what? 1 kg per liter. Because we are already having mass in kgs, that what we have chosen that value of density. Okay, that is 1 kg per liter. So volume would be 2. So here what would we put? 2. When we would solve it, that is what? 20 divided by 2. So what would we get? 10. We would get 10 parts per million. Just here we would put what? 20, and here we would put what? 2. So the answer would come out to be what? 10 parts per million. So our correct option would be this, the 10 parts per million. Okay, this is what? The hardness of the water in parts per million. Clear? First of all, we would calculate the mass of calcium carbonate, and then we would calculate the volume of water in liters. Clear? Now the next question. Identify the pair of chlorides that are responsible for the permanent hardness of water. Right now I just told you that the permanent hardness of water is due to what? Calcium chloride and magnesium chloride. So our correct option would be what? This option number 4. Okay, magnesium chloride and calcium chloride. These are responsible for what? For the permanent hardness of water. Next question. The cell that is formed in the banked pipes. Banked pipe means the pipes that are deformed in the banked pipes. There are what? It's stress. There is what? Is stress, because the metal is what? Bending. So the type of cell that is formed over there, it is what? Is stress cells. Okay. Stress cells are formed in banked pipes. So the banked pipe, the cell formed in the banked pipe, it is an example of what? Stress cells. Okay. Next question. Tarnishing of silver is due to the formation of, see, tarnishing of silver, it is due to this silver sulfide. Okay, we know that the tarnishing of silver is due to what? Silver sulfide. So it's sulfide layer. So that would be the correct option. Tarnishing of silver, it is due to what? It's sulfide layer. Not sulfate, not nitrate and not chloride layer. It is due to its what? Sulfide layer. Okay, it is due to what? Its sulfide layer. So the correct option would be option number 3. The next question. Which of the following is not a copolymer? Okay, now the next question is what? Which of the following is not a copolymer? So see, the Buna-S rubber, it is a copolymer. Buna-S. Okay, it is a copolymer of what? Butadiene, that is 1,3-butadiene plus styrene. Okay, so it is a copolymer. Then neoprene rubber, this is not a copolymer. It is simply a polymer of 2-chloro-1,3-butadiene. Okay, and it is also known as what? Chloroprene. So it is a polymer of that. It is a polymer. It is not a copolymer. So our correct option would be neoprene rubber. Okay, bakelite. Bakelite, it is again a copolymer of what? Phenol and formaldehyde. Okay, bakelite, it is a copolymer of what? Phenol and formaldehyde. And urea formaldehyde, so it is already given in the name itself that a copolymer of urea and formaldehyde. So the correct option would be what? Neoprene rubber. It is not a copolymer. It is formed by the polymerization of what? Chloroprene units. That is 2-chloro-1,3-butadiene. This polymerization of chloroprene. So the correct option would be what? Neoprene rubber. Very easy question. Okay, directly from the theory. Next question. The monomer involved in the formation of polystyrene. See, polystyrene, as it is clear from the name, polystyrene. It would formed by what? It would be formed by the polymerization of styrene. What is styrene? This. This is what? Our benzene ring. So we can also write it like this. 6,6H5. CH double bond CH2. This is what? Styrene. Okay, this is styrene. So its polymer is what? Polystyrene. So our correct option, no, this is not. This is what? Vinyl chloride. Not. This is vinyl cyanide. This is what? Propene. So no. Yes, this option number 3 is what? Our correct option. Okay. So our correct option would be option number 3. Now the next question. We can overcome the undesirable properties of the natural rubber by heating natural rubber with. So we heat natural rubber with what? Sulfur. Okay. We heat natural rubber with sulfur, and this process is known as what? Vulcanization process. Okay. This is known as what? Vulcanization of rubber. And as a result, we get rubber with better qualities. Okay, we get what? Rubber with better qualities. So the correct option would be what? Sulfur. Okay, we heat natural rubber with what? Sulfur. And this is known as what? Vulcanization of rubber. Next question. Liquefied petroleum gas mainly contains. So in liquefied, when we talk about LPG, it mainly contains what? Butane and isobutane. Okay, it contains mainly what? It is a mixture of what? Butane and isobutane. Okay. Theoretical questions. Now we are having what? Theoretical questions. Now greenhouse effect. Greenhouse effect is mainly caused by the increasing concentration of what? Carbon dioxide. Carbon dioxide, it is the main gas responsible for what? Greenhouse effect. CO2 is now increasing in the atmosphere and causing what? Greenhouse effect. So oxides no, no carbon monoxide no, nitrogen monoxide no. What is this? CO2. Okay. The correct option would be what? CO2. Carbon dioxide is responsible for what? Greenhouse effect. And our last question. Which compound is mainly responsible for the depletion of ozone layer? Well, mainly responsible are what? Chlorofluorocarbons. The compounds that are responsible for what? For the depletion of ozone layer are what? Chloro. This is responsible for greenhouse effect. Not methane, not methanol, but what? Chlorofluorocarbons. Dichloro, difluoro, methane. This is what? Dichloro, trifluoro, methane. Okay, so this is responsible for what? For the depletion of ozone layer. Clear? So the compound that would be mainly responsible for the depletion of ozone layer is what? Chlorofluorocarbons. Okay, so these were all the questions of the chemistry part. Okay, the 25 questions of the chemistry part that we have been discussed. Okay, thank you.